In this problem, we are going to be using our graphing calculator to create a table and graph of a function using different viewing windows. You're going to learn a little bit about using the window part of your calculator. So consider the function f of x equals 5 minus 2x. Use your graphing calculator to complete the table below. So what we're going to do is we're going to press y equals, and we're going to enter 5, subtract 2x. So that's our function. We are entering that into y1. Then I want to go to my table set to be sure what kind of values I'm going to be looking at in how my table is generated. So second table set will take me there. My table is going to start at 0. That's good. My table is going to increment. This is delta table, is going to increment by 1. And my independent, that's my x variable, is on automatic, as is the dependent or output variable. So all of that is good. The only time I'd want to change independent to ask is if I had a lot of input values that were very far apart and I didn't want to scroll between each one, then I would change independent to ask. But here, this looks like a good setup for us. To get to my table is above graph, so I'm going to press second and then the graph button. That will give me my table. So I can just read a lot of the values right off the table. So when input is 0, output is 5. When input is 3, output is -1. When input is 7, that's beyond my table, so I can use my arrow down to get to 7. 7, input, output, -9. I'm going to keep going to get to 9. I have an output of -13. And to get to 12, I have an output of -19. For part B, I want to use my graphing calculator to sketch the graph on the standard viewing window. That's the window from -10 to 10 in each direction. So let's see what our window is now. So this window is not the standard window. I could either change x-min to -10, x-max to 10, y-min to -10, y-max to 10, or I can press the zoom, and number 6 is standard. So if I press 6, it's going to give me the graph on a standard window. So all I did was to transcribe what I see here in the graphing window over into my space in the workbook here. So I've got my x-axis here, my f of x axis here. Let's see if I can write that a little bit better. And then I just drew a sketch of the graph here. Now for part C, we're going to use our graphing calculator to sketch this graph again, and we're going to change the window. So go back to window, change x-min to 0, x-max we want at 3, y-min, I'm going to skip the scale, I don't really ever change that, y-min is 0, and y-max is 5. So let me press graph again. And we can see that the graph looks quite a bit different than the one that we have here. So all I did was to transcribe again the image from the calculated graph on the left into the workbook here. So again, this is my x-axis, this is my f of x axis, and here is my graph. So I'm going to recommend that you pause the video, take a few minutes, and try to notice what the similarities and differences are in the graphs, and then write your answers here and then compare with the video when you restart the video. So these graphs are of the same function. However, the second graph uses only first quadrant or all positive values. There are many times when we're working with application problems that we only are concerned with values of our graphs that are in the first quadrant. So it's important to understand how to change your window to reflect only values in the first quadrant. So if you look at the graph from the first window, and you look here in the first quadrant, and you blow that up a little bit, you have exactly what we have here. So it's not like the other parts of the graph don't exist. It's just that what we're doing here really is we're zooming in to just the positive parts of the graph in the second graph.